In this video we're going to be looking at electric current. Now, electric current is carried by discrete charge carriers. Charge is conserved at all points in an electrical circuit. You need to be able to distinguish between electron current and conventional current. You need to be able to define electric current as the rate of flow of charge. And you need to be able to solve problems involving the following equation, which is capital I stands for current, Q is charge, and T is time. So we're going to look at this in more detail on the following slides, but charge is the rate of flow, current is the rate of flow of charge. So it's the amount of charge which is measured in coulombs per time, which is measured in seconds. So you need to know that electric current is carried by discrete charge carriers, and charge is conserved at all points in an electrical circuit, and you need to know that electric current is the rate of flow of charge. So, as we know, in solid conductors there are many free electrons, so those are those valence electrons, and they're not bound to their atoms. Now, it is these electrons that make up an electric current when they flow. So, the electric potential difference applies energy to each unit of charge, so it gives them energy, and then they're able to flow around the circuit, and electrons flow from the negative terminal to the positive terminal, because they want to repel away from the negative terminal and reach a point of less energy, which will be at the positive terminal. Now, at all points in a circuit, charge is conserved, okay, because electrons cannot be created or destroyed, they're only transferred, and they're transferred around the circuit, they're pushed around the circuit. So charge is conserved at all points in the circuit. And we'll use this idea to look at current at different points in the circuit later on, depending on what circuit they're going through, what components are in the circuit. Now, as I've mentioned, current is the rate of flow of charge. So it is the amount of charge per unit of time. So if we have a circuit, we have some point in the circuit, and we have 5 coulombs of charge passing that point, and it's taken 5 seconds for those 5 coulombs of charge to pass, then 5 coulombs divided by 5 seconds means that 1 coulomb is going to pass that point every second. So charge is measured in coulombs per second, but this coulomb per second is actually called an amp, or an ampere. So 1 amp is equal to 1 coulomb of charge per second. And 1 amp, okay, so 1 coulomb of charge per second is a ton of electrons per second. 6.254 times 10 to the 18 electrons per second. So 1 amp is an absolute massive amount of electrons passing a point per second. So just to reiterate, you need to know that current is the rate of flow of charge, and this equation for current, current is charge per time interval, so it's coulombs per second, and coulombs per second is an amp, so you need to be able to define that. Now, this bit's going to annoy you, but you just need to suck it up and go on with it. You need to distinguish between electron current and conventional current. Now, before they knew what particles moved, they actually thought the particles that moved in a circuit were the positive particles. So they thought that the particles flowed in the direction of these red arrows. So they thought that charged particles flowed from the positive end of a battery to the negative, because they thought they were positive. So this is the convention that they came up with, that current was from positive terminal to negative terminal. Okay, now pretty much for some strange reason they've never actually made the swap. So we now know that electrons are the charge carriers that flow around a circuit, and we know they flow from the negative end of a battery to the positive end. Now we know this, however, a lot of physics, both at high school level and university level, still use the convention of the convention of current going from positive to negative. So this is what we call conventional current, and this is what we call electron current, or sometimes we refer to it as electron flow. you need to be able to distinguish between them. Electron current, negative to positive, because that's repelling away from negative, flowing towards the positive terminal. However, conventional current, and when we're analysing circuits, which we will do in this topic, and we'll also look at magnetism, well, you might look at magnetism later in your schooling, we're also going to use conventional current, so from positive to negative. Now, we looked at measuring voltage with a voltmeter, and a voltmeter needed to be connected in parallel across a component or parallel to a circuit. Now, an ammeter is used to measure the electric current at a point in the circuit. So it's placed in series, so in a row, one off. So after an appliance or a component in the circuit, the ammeter is placed, so connected with your alligator clips. So it's placed in series, through which the current is to be measured. And basically what it does is it detects the amount of charge passing this point for a given amount of time. So charge per time interval, which is what current is. The amount of the amount of charge per second. Now, as I mentioned earlier, this is the equation for current, charge per time interval. So you need to be able to rearrange this. So you need to be able to solve for current, for charge, and for time. Now, in this example, in a thick copper wire connected directly across the terminals of a car battery, a current of 16 amps is produced. What charge flows past the point in the wire in 5 seconds? So, what do we know? We know in the question, we know that we have a current of 16 amps, so we've got current. We know the amount of time, it's 5 seconds. So we're solving for charge. So in part A, we're solving for charge. So we're solving for Q. And if we were to rearrange that equation, we'll multiply both sides of the equation by T. So it'll be current times time. So we know the current at 16 amps times by 5 seconds. So it's going to be 16 times 5, 32, 64, 80. So it'll be 80 coulombs of charge. Now, part B. How many electrons flow past the point in 5 seconds? So if there's 80 coulombs of charge, so number of electrons, I'm just going to use this symbol for number of electrons is equal to 80 coulombs, and each electron only has an absolute tiny amount of charge, so 1.6 times 10 to the negative 19. And I am going to have to use the calculator for this. So 80 divided by 1.6 x to the negative 19. 5 times 10 to the 20. 5 times 10 to the 20. So an absolutely massive amount of electrons. So obviously you might need to rearrange this equation, so we can also, so if you're finding current, it's just as it's given, and if you want to find time, they will just swap spots. So for time, you'll have charge over current. So just to reiterate, current's the rate of flow of charge. So 1 amp is equal to 1 coulomb of charge passing a point in 1 second. So 1 amp is 1 coulomb per second. So I now want you to do questions 29, 30, 31 and 32 in your textbook. Have a crack at them and let me know how you go. See me if you have any issues. Thanks.